Okay, so we are talking about inverse, sine, cosine, and tangent functions. Note, a function, okay, remember, a function by definition is where your domain elements don't repeat. So it passes that vertical line test, yeah? What it means is, for every input, for every x value, there is one and only one corresponding y value. So a function has an inverse if and only if it is a one-to-one function. Okay, it has to be, and it actually should be, a function has an inverse function. Add that word in there for me, please. If and only if it's one-to-one. Now, what does that mean? Well, to be one-to-one, you pass not only the vertical line test, but you also pass the horizontal line test as well. The mathy definition behind this is for every x, there is one and only one corresponding y. Okay, that's the function piece. And in reverse, for every y, there is one and only one corresponding x value. So we would say not one-to-one is a parabola. Okay, yes, it does pass the function vertical line test, but if I were to test it with a horizontal line test, I have two x values that correspond to one y value. It's not one-to-one. An example of a function that is one-to-one would be a cubic without really any vertical compressing. Okay, if we took our horizontal line, we would cross it just once. Now, the reason this is so important is because when we talk about sine, cosine, and tangent, these aren't one-to-one functions. If you look at the sine function, yes, it's a function, right? Our vertical line test passes wherever we are on the curve, but it's not one-to-one. Yes, the domain is all real numbers. Whoopsies. Yes, the range goes from -1 to 1 inclusive. But if I were to test with a horizontal line, I'm going to encounter the curve numerous times, meaning that it's not one-to-one. So in order for a sine function to have an inverse function, we have to restrict the domain. And the sine function's domain is restricted such that -pi/2 is less than or equal to theta, which is less than or equal to pi/2. Theta being the input, the x values, the domain. If you'd like to write it as -90 degrees so you can see the correlation, that is fine as well. But know that we'll be dealing in radians for the inverse. Ah, barnacles. I knew that was going to happen. Happened to me yesterday too. Consistency. Okay, so if we restrict the domain, that means we're only looking at a certain part of the sine function. We're going to cut it out, yeah? And it's going to exist from -pi/2 to +pi/2. If we restrict the domain, this is the part that we're going to have for our inverse sine. So graph that with me, please. And a couple things to remember about inverses. We saw this year. You've seen it in Algebra 2 also. Inverse functions. Think about a square and a square root. Right? Those are inverses. They undo each other. So if we have sine and then inverse sine, it's always noted with that -1 exponent. You're also going to see it written as arc sine. Sine, cosine, tangent, we're dealing with rotations, the arc of a circle. So arc sine also applies to the inverse of sine. Things to know about inverses: their x and y values switch. They're reflective across the line y equals x. These characteristics hold true for every pair of inverse functions. So if we go to graph it, our y values are not negative 1 to 1. Those switch. That becomes our x-axis. The sine function has an x-axis that is in radians, so its inverse will have y-axis values that are in radians. Why is that negative? There we go. This sine function has a point within the restricted domain at negative pi over 2 comma negative 1. Therefore, its inverse will have a point at negative 1, negative pi over 2, all because the x and y values switch. So negative 1, negative pi over 2. Sine has a coordinate at 0, 0, so its inverse will have a coordinate at 0, 0. Sine has a point at pi over 2 comma 1, so its inverse will have a point at 1 pi over 2. And how do we connect it? We connect it in a very funky looking curve like that. Now, if their x and y values switch, guess what? That means that the domain and range elements also switch in between inverse functions. So if the domain of sine of x is all real numbers, well, usually that means that the range would be. But remember, we restricted the domain. So this range is now from negative pi over 2 to positive pi over 2 inclusive. Inclusive means brackets. We have closed points at those locations. The range for sine was negative 1 to 1, which means the domain for the inverse is going to be negative 1 to 1. Now, I'm not going to ask you on a test to graph the inverse, but it's on our notes because you need to understand where the restrictions come from and why for all three of our inverses, because we're going to evaluate inverse expressions, and you need to understand that all of them are restricted in the domain because the function's not 1 to 1. Okay? Wait, evaluate expressions. What? Enter in example number 1. Yeah. Okay, there's a big difference between evaluating an expression and solving an equation. When you're evaluating a trigonometric inverse expression, okay, expressions means there isn't an equal sign, you have to adhere to the restrictions on the domain. Yes, you might want to write that down. When you're evaluating an expression, you have to adhere to the restrictions on the domain. So example 1a and 1b are expressions. That means that we're going to have to adhere to the restrictions on inverse sine. And if we think about our Cartesian coordinate plane, we go from 0 to negative pi over 2. And then we would go from 0 to pi over 2. We do not include the second and the third quadrant. Okay, so if you think about, this was A, S, T, C, the restrictions on the sine domain are such that you'll get all of the positive sine values in the first quadrant and all of the negative ones in the fourth quadrant. The restriction accounts for all possible values. Okay, both positive and negative. So let's take a look at A. When you're asked to evaluate, you're asked to find what this equals. Okay, so inverse sine of 0 is what? Well, this is new to us, and it may not be very comfortable in this format. You can rewrite it. You can rewrite the inverse. We can say that if we take the opposite, well, shoot, the sine of what angle measure is going to give us 0. It's the same as if I were to say, okay, x squared is equal to 4. Well, you can tell me x is equal to the square root of 4. Those are inverse functions. So if I have the inverse sine of 0 equals x, you can rewrite it to be the sine of x equals 0. So think about the restrictions on the domain. We already know that we can't exist in the second and the third quadrant because the restrictions on the domain limit us. We need to figure out what angle measure gives us a sine value of 0. Ethan? 90. Cole? 0. Two very good guesses. Let's see. If we're at 90, our coordinate is 0, 1. Which part is sine? Is it the x or the y? It's the y. Yeah. So unfortunately, even though it was a good guess, it can't be that one. If we're at 0, the point is 1, 0. Does that fit? Yeah, absolutely. So you want to think, and if you're not super comfortable with your unit circle, now would be the time to reacquaint yourself with it. But have it out with you, okay? That's why we take notes. So we would say that x is equal to 0 pi, or you can say 0 degrees. Okay, we're looking for the angle measure. Just like when you did basic right triangle trig in geometry, the inverse trig functions, you're looking for the angle measure. If you need to write that down as a reminder, write that down, okay? The inverse trig functions, you're finding the angle measure. All right, so inverse sine of negative rad 3 over 2 equals what? We're looking for that angle measure. Well, if you need to rewrite it, you can always write it as the sine of x is equal to negative rad 3 over 2. I'm thinking about the restrictions, and you don't have to draw this, but it helps me. I'm visual, so I'm drawing it. We aren't in the second or the third quadrant. Now, since sine is negative, right, we're looking for an angle measure that gives us the sine of negative rad 3 over 2. We're not going to exist in that first quadrant. I need to find a reference angle in the fourth quadrant that's going to give me a sine value of rad 3 over 2. Anybody? Use your notes if you need to. I'll give you a hint. It is not a 45-degree reference angle. So that narrows it down to 2, 30 or 60. What angle measure has a sine ratio of rad 3 over 2? One half is a good guess, but be careful because we're looking for the angle measure, yeah, not the side ratio. We already know that the side ratio needs to be rad 3 over 2. Steve, 60. Ooh, good guess. What do we think? Huh? Ooh, 30. 30, 60. Cool. Okay, so we've got two that are saying 60. I do concur. Cole said that if we rotate 300 degrees into that fourth quadrant, we get a sine ratio of negative rad 3 over 2. You are correct. Steve, huh? What? Well, hang on. Good question. We're getting there. I asked originally for the reference angle, right? And the reason being, Cole isn't wrong. If we rotate around 300 degrees, we get to a location where the reference angle is 60. Think about the restrictions on the domain. Is 300 degrees within the restrictions on the domain for sine? Yeah. The restrictions on the domain are between negative pi over 2 and pi over 2, which means if I start at the positive x-axis, I'm either going to go up to pi over 2 or I'm going to go down to negative pi over 2. Sine gets tricky because of this particular restriction. So do me a favor. If you're asked to find the inverse sine of a negative side ratio, figure out what the reference angle is only, and that is your answer in the negative rotation. So this would be negative pi over 3, so that it fits within that restriction. Okay, I can't rotate all the way around to 330, even though it's a coterminal angle. It's that same location to what we're looking for. It has to fit within the domain restriction. So look for the reference angle. Does that make sense? Cool. Okay. All right, last example for example number 1. Ooh, it's an equation. That's exciting. However, remember back to Algebra 1 when you were solving multi-step equations and we introduced the alphabet and you're like, whoa, what happened to my numbers? You always have to isolate the term with the variable. So I can't solve this right away. I'm going to need to divide both sides by 6 because I have a 6 in front of my variable term. So we'll say that the inverse sine of x is equal to pi over 6. And it's not an expression, so I'm going to rewrite this to make it look a little more user-friendly. I'm going to say, well, the sine of pi over 6 is x. What is x? Well, pi over 6 is what in degrees? 30, good. So what's the sine of 30 degrees? 1 over 2, nice job, yes. So this just equals 1/2. Okay, 2 different approaches to the inverses, but the process is the same. You can rewrite it into a little bit more comfortable format if needed. Okay, the big thing is remembering the domain restrictions. Let's look at cosine. Cosine is also not a one-to-one function. So, you guessed it, we're going to have to restrict its domain. Mathematicians decided back in the day that we're going to restrict the domain from 0 to pi. In other words, we're going from 0 degrees to 180. Now, before we restricted the domain, yes, we knew that the domain was all real numbers. And the range was the same as cosine, negative 1 to 1 inclusive. Okay, if we restrict the domain from 0 to pi, that means we start at 0 for x and we go all the way to pi, representing both positive and negative values for cosine. Let's graph the inverse, which is just that highlighted piece. Remember, for inverse functions, your x and y values switch. So that means for the inverse, its x-axis is going to go from negative 1 to 1. and the y-axis is going to have the radian measures. On cosine, we have a point at 0, 1, which means the inverse will have a point at 1, 0. Because again, the x and y values switch. On cosine, we have a point at pi over 2 comma 0, which means we'll have a coordinate at 0, pi over 2. And on cosine, we have a coordinate at pi negative 1, which means we'll have a coordinate at negative 1 pi. And then we'll connect these in a somewhat strange-looking curve again. Make it a little bit bigger if you guys need it. And we can see that the domain goes from negative 1 to 1, which is the range of the inverse, followed by the range being 0 to pi, which is the restriction. Remember that the inverse can be written as either arc cos, or you can write it as cosine to the negative 1 exponent. Okay, so if we are restricted between 0 and pi, that means that we are only in the first two quadrants. Okay, so the restriction on inverse cosine is from 0 to pi. That means we're not looking at quadrant 3 or 4 when evaluating expressions. So example 2a is asking us to evaluate the inverse cosine of negative 1/2, and there should be parentheses. So basically what we're looking for is what this equals. If you're not comfortable with the format, change it. You can rewrite it as the cosine of x is equal to negative 1/2. What angle measure makes this true? Well, if you need that visual again, go ahead and draw your x and y axes. Cross out the third and fourth quadrant because those don't fit into the domain restrictions. And since cosine is negative, we're not going to be in that first quadrant. We're going to be in the second quadrant. So we need to figure out what angle is going to give us a cosine of negative 1/2. The cosine of what angle measure is negative 1/2? I'll give you a hint. It is not a 45-degree reference angle. It's a terrible hint. Cole?
5 pi over 6.
Pardon? 5 pi over 6. So 30-degree reference angle?
Yeah.
Okay, that's one option. Okay, so Cole's taking a guess, and he's saying 5 pi over 6, which is in that second quadrant. It's a 30-degree reference angle. Do we agree or disagree? Penelope's shaking her head no. Penelope, why are you shaking your head no?
I said it's 2 pi over 3.
2 pi over 3. I actually concur. It is 2 pi over 3 because if we are a ratio of 1/2, it has to have a 30-degree reference angle. But Cole, I appreciate you trying. So we can say 2 pi over 3 or 120 degrees. All right, take a look at B. What angle measure is going to give us a cosine of 0? Again, think about your restrictions. We are not in the third or fourth quadrant here. We are only existing from 0 to pi. Where is cosine 0? Yeah? Is it? Yes, Ethan, good job. It is going to be 90 degrees this time. The point up at that positive y-axis is 1, 0. No. Is 0, 1. That's exactly what we need. Sorry for making you guess, Ethan. So x is pi over 2 or 90 degrees. All right, one more example for example number 2, and then I'll take questions if you have them, although you guys are great about asking questions when you need. It's not just 3. There we go. All right, so here it's not just an expression. So we are going to have to move some things around. We need to isolate the term with the variable. So let's divide by 3. We get the inverse cosine of 2x is equal to 2 pi over 3. Don't worry about the fact that there's a 2 being multiplied to the variable. We'll deal with that, right? Right now, I'm going to rewrite this as the cosine of 2 pi over 3, and it's equal to 2x. What is the cosine of 2 pi over 3? Yeah, very good. Negative 1 over 2. So we get 2x is equal to a negative 1/2 ratio. But then we have to divide by 2. And remember, when you divide by 2, for those that need to see it, divide by 2. We are ultimately multiplying by the reciprocal. So we get x is equal to negative 1/4. Nice. All right, any questions up until this point? We've only got tangent left, and then we'll start our homework. No? Okay. All right, let's take a look at tangents. Notice this can be written as inverse tangent with that exponent or arctan, just like the others. This is not a one-to-one function. None of them are. So in order for tangent to have an inverse function, we're going to restrict its domain. And we're going to restrict it to be between negative pi over 2. But notice, this one is not equal to. Tangent is undefined at pi over 2, so it's just less than. Okay, this is the only one where the restrictions are not equal to because the function's undefined. And what does that look like? We include these asymptotes, we include this curve, and we include that asymptote. Now to fill in the domain and range, normally our domain is all real numbers. This is without the restrictions, okay? This is for the parent function. But x cannot equal an asymptote location plus the period k, where k is any integer. And the range is all real numbers. All right, now the inverse, again, you can write it with the negative 1 exponent if you would like. Let's graph it. This one's kind of fun because we do have the asymptotes. Just like we saw with inverse sine and inverse cosine, our x and y values are going to switch. So my x-axis is going to go from negative 1 to 1. And my y-axis is going to be listed in radians. Okay, we have asymptotes. They are vertical for the tangent function. If our domain and range values switch between inverse functions, that means they are now becoming horizontal asymptotes. So the inverse is going to have a horizontal asymptote at pi over 2 and at negative pi over 2. We do have a coordinate at negative pi over 4, negative 1. So we'll have a coordinate at negative 1, negative pi over 4. We do have a coordinate at 0, 0, so the inverse will have a coordinate at 0, 0 as well. And we have a coordinate at, oh fudge, wrong color, there we go, at pi over 4 comma 1, so that means we're going to have a coordinate at 1 pi over 4. Making sure when you draw it in to not cross those horizontal asymptotes, please. They are boundary lines. Now for our inverse, their domain is all real numbers this time around. And we can see that the range goes from negative pi over 2 to positive pi over 2, non-inclusive. So we have parentheses to show that the function does not exist at those radian measures. Sweet! All right, ladies and gentlemen, example number 3. All right, for example 3a and 3b, they are expressions, so we have to adhere to the domain restrictions. For a, we're looking for an angle measure. I don't know why my pen just froze. Yikesies. That will make this equation true. Tangent of what is equal to negative 1? What radian or degree measure? Well, if we think about the restrictions, it is the exact same domain restrictions as sine, so it doesn't exist in the second or the third quadrant. Since this tangent ratio is negative, we're not in the first quadrant either. We need to find an angle measure in the fourth quadrant that will give us a tangent value of negative 1. Any guesses? Okay, I'll give you a hint. It's 30, 45, or 60. Aha, 45. Good guess. Yes, it is 45 degrees. And remember, this is the weird restriction, just like sine, where we either rotate up in the positive direction or we're going to rotate down in the negative direction. So we don't want to say that it's 315 degrees. That doesn't fit in the restriction. We don't want to say positive 45. Our answer should be negative pi over 4, or you can say negative 45 degrees. If you think that's going to trip you up, please, please, please make a note on your notes right now to pay attention to that negative rotation for inverse sine and inverse tangent. All right, inverse tangent of positive rad 3 over 3. So what angle measure, if I take tangent of that angle measure, is going to give us a positive rad 3 over 3? Well, I know that I can't look in the second and third quadrant. That's not within the restrictions. And the ratio is positive. So I'm not going to look in the fourth quadrant. We need to be in that first quadrant, which is nice because it's either going to be 30, 45, 60. We don't have to do any addition or subtraction here. So what is that angle measure?
30.
30. Nice job. Yes. So we would say pi over 6 or 30 degrees. Sweet! Are some of you thinking now, man, I really should have paid attention to that unit circle? Now's the time! Hey! Hopefully you still have your notes. All right, last but not least, we have another equation. We have to isolate the term with the variable, so let's divide by -8. We get the inverse tangent of x is equal to 4 pi over -8, which gives us a negative pi over 2. Well, it's an inverse of a variable, so let's rewrite it. Let's rewrite it as the tangent of negative pi over 2 equal to x. What is the tangent of negative pi over 2? You have your unit circle, you've got that trig ratio chart, we have the graph that we just graphed a minute ago.
Wouldn't it be undefined?
Yes, nice job, it would be. Very good. So x is unfortunately, or fortunately, depending on your opinion, undefined. Sweet. All right, ladies and gentlemen, I have 3 that I would like you to try on your own, please.